Matrix inverses and equations. So you're familiar with using inverse operations to solve equations. The inverse of addition is subtraction, the inverse of squaring is taking the square root, and so on. Matrices also have inverses that can be applied to solve equations. To find the inverse of a 2 by 2 matrix, we'll define matrix A as being the matrix with the entries A, B, C, and D. To find the inverse, the formula is 1 over AD times BC. You multiply diagonally and subtract. And then inside the matrix, you have D, negative B, negative C, A. Basically what's happening is from the original, the A and the D are changing positions, and the C and B are changing signs. Also, just so you know, AD minus BC all by itself is called the determinant. So suppose I want to find the inverse of matrix A, and it's negative 2, 5, negative 3, 4. So the inverse is 1 over the determinant, which is I multiply diagonally, negative 8, minus, multiply diagonally, negative 15, which would be negative 8 plus 15, which is positive 7. Sorry. So 1/7 is on the outside, and then on the inside, the negative 2 and the 4 change positions. The negative 3 and the 5 change signs. So the 3 becomes positive, the 5 becomes negative. Now then distribute the 1/7 to everything inside, and our inverse is 4/7, negative 5/7, 3/7, and negative 2/7. And that's the inverse. We can use matrices and their inverses to solve systems of equations with more than one variable. So you see this system with 2 equations and 2 variables, x and y. We can write this in matrix form with the coefficients in matrix A, the variables in matrix X, and the constants in matrix B. So here's what that would look like. In matrix A, we put all of the coefficients, 5.4, 4.2, 3.7, 6.4. The variables go in matrix X, X and Y. And then it equals matrix B, which are our constants, negative 12.9 and negative 4.5. So if you remember from our last lesson how to multiply matrices, if you multiplied these back out, you would end up back with the 2 original equations that we have. Now we know when we're solving, we want to get x by itself. And by x I mean the name of the matrix, this x right here. We want it to be by itself so we know what x and y are. So we need to cancel out the a. Well, just like in any equation, in order to cancel something, we apply the inverse to both sides. So this is our equation. We have matrix A times matrix X equals matrix B. And if I want rid of the A, I need to multiply by the inverse on both sides. The inverse and the original cancel each other out. And I know that my solution matrix then is equal to the inverse of A times B. Now we could calculate the inverse of A by hand with the method I just showed you in the previous example, and then take that result times B, and we would end up with what x and y equal. But our graphing calculator can do this for us. So we're going to use the graphing calculator. And like we wrote just a minute ago, in matrix A, we'll have all of the coefficients. Matrix B will be the constants, and we need to enter those into the calculator. So these are the steps to do that. First, we're going to push the button that says second, and you can see matrix written right above the x to the minus 1 button. So we're accessing matrix. Second matrix, the right arrow 2 times, that's what that little 2 means, and then enter. We're trying to get to the menu option edit. and we enter when we're on editing matrix A. So we go to Edit and we choose A. Once we get to matrix A, you'll have to enter in the dimensions. It's a 2 by 2, and then you enter in all of the little entries, the 5.4, 4.2, and so on. Make sure you push enter after each one, especially after the last one. Sometimes it's easy to forget. So now matrix A is entered in. Then you're going to go back and get back into the matrix menu, second matrix, arrow twice over to edit, and this time you're choosing number 2 because you're editing matrix B. Put in matrix B's dimensions, it's a 2 by 1, and then the entries, pushing enter after each one, negative 12.9 and negative 4.5. Now that you've entered in matrix A and matrix B, we need to get back to the home screen, so you'll push second quit to take you back to the home screen. Now what we're trying to get is the inverse of A times B. So first of all, we call up matrix A. You'll push second matrix and then just enter because you'll be right on A. Then we need the inverse, and that's just simply the x to the minus 1 button. That gives the little negative 1, the inverse beside matrix A. Then we need to call up matrix B. So second matrix and choose number 2, which is matrix B, and enter. And then this is what you should have on your screen. A inverse B. Sometimes the little negative 1 gets forgotten and then you won't get the right answer. So make sure you get that little inverse negative 1 in there. And then after you've hit enter, you should have the solution. So what that means is in the two equations, we've solved x is negative 3.35, y is 1.23. Now when you're dealing with two equations and two variables, it's really not any faster to use the calculator and matrices. You could do elimination or substitution, and that's just as quick. But with equations and three variables, it's much faster to use matrices and the calculator. So we're going to solve this system of three equations and three variables for x, y, and z. And any variables that we're missing, we'll fill zeros in for those. So matrix A, the top row represents the first equation, 2, 0, 1. Middle row is the second equation. Third row is the third equation. And so matrix A is a 3 by 3. Matrix B are our constants, negative 5, negative 6, negative 9, and it's a 3 by 1. So you'll go back to those same steps to enter in matrix A and B. You'll edit and put in A, edit again, put in B, and then second quit to get back to the home screen. And then once you're back to the home screen, you'll call up matrix A, you'll push the inverse button, you'll call up matrix B, and you'll hit enter, and you'll get the solutions. So what that matrix means is that x is negative 3, y is 2, z is 1.